Hello, everybody. My name is Steve Levine, and I want to thank you for taking the time to attend this webinar. Our focus today will be on a practical application of natural language understanding proven to save time and money. Today's agenda will start off with Michael providing a brief background on artificial intelligence, natural language understanding, and how cortical.io's approach is different. We'll then move into an overview of contract intelligence. And then finally, Sascha will provide his perspective of PwC Germany's experience using contract intelligence and cortical.io for other text mining projects. Now, over to you, Michael.
Thank you very much, Steve, and hello, everyone. Welcome to this webinar. So my role here is to provide a little bit of background on AI. I know you as an audience are interested in contract intelligence, so I'm not going to go into technical details, but I think you're also, I'm sure, curious to know a little bit about the AI that's behind Cortical's technology, and hopefully I'll be able to provide a little bit of background and context for you on that. So my first job, if you like, here is to level set. What do we mean when we talk about AI? Because there's a lot of confusing messages out there on the media. This slide really provides a very high-level view of the very topical areas of AI today. AI itself is an umbrella term for developing systems that have human-like intelligence. And the one that is making a lot of noise at the moment is deep learning. I wonder whether you have heard of that. And that's based on neural networks, which is part of the machine learning area of AI. Now, Cortical's technology lies outside the gray area, so it's more in that sort of dark blue-gray area of AI. And I'll hopefully explain to you a little bit more about why that is and why that is actually, I find, very exciting. If we look at where we are in terms of our evolution of artificial intelligence, I would say that where we are now, you could call machine intelligence or assisted intelligence, and it is a little bit before where the next milestone, which would be artificial narrow intelligence. And then further down the line, I believe a little bit of faith there that we will improve our technology to the point where we will achieve the milestone of artificial general intelligence. And AGI is where the artificial system is equal to the capability of the human brain. And then, of course, after that come all kinds of social issues and the scary bits about singularities and transcendence. We're not going to talk about that. I think that's very much in the future. So where we are now, machine intelligence, very exciting technology. And let me then tell you a little bit about what Cortical is doing and as I said, why I'm excited. So this chart provides a historical overview of the development of AI over the years. And if you look at that first plateau between 1958 and 1986, that plateau, which is today called an AI winter, was largely due to a book that was published by Minsky and Papert back in 1969. And it really dried up funding for neural networks because at that point in time, you didn't have a neural network that had a hidden layer. There was just an input and an output. You couldn't train anything in between. And it was in 1986, 85-86, that backpropagation was created, and that allowed the hidden layers to be trained, and that opened up. We go back to that slide. You see a new surge around 86, and that's when I actually got involved in neural nets and built neural nets. Ultimately, that turned into a second AI winter because the computational capabilities were limited. And then in 2010, on that chart, you see that number 2 there, deep learning came into being. But really what made it possible is the hardware. GPUs could run the algorithms, and the computational capability really took off. And then the neural networks could have very, very deep layers, and that's why they were called deep neural nets. But one has to understand that this technology with deep learning does have limitations. It's very much about technology that is engineering-oriented. It has some hints from the way the brain is structured, but that's about it. It also takes a lot of training to teach the deep neural network its task. Thousands, sometimes millions of iterations are needed. And these systems are good for very narrow applications, and every time they have to be rebuilt. Deep learning is useful. It has lots of amazing real-world applications, but ultimately it's going to be limited in terms of some of those later milestones that I mentioned earlier for the future of AI. Now, back in '88, which was around the time that the backpropagation was invented, there was this research produced by Canerva on sparse distributed memory. And this was later taken up by an organization called Numenta. Let me before I go into how this became quite interesting today, let's just take a look at an example of a sparse distributed memory or representation. So this array that you see with the blue dots on it represents 2048 bits, and it's shown in 2 dimensions, so in layers. And if we consider vectors that have 40, that only have 40 bits that are on, so vectors that have a length of 2048, but only 40 of those bits are on, so they're very sparse vectors. Most of the vector have zeros. The capacity of the SDR to hold those types of vectors is absolutely enormous. If you look at the red circle in that chart, you'll see that it's a number that has a lot of zeros after it. So that represents this huge capacity that this type of memory holds. So if we go into some of these characteristics, first of all, as I mentioned, it's sparse. There's lots of zeros, so computationally it can be, you can use sparse matrix techniques, and it's highly efficient. It's a distributed representation, so it's very resilient to failures of a few noisy bits that may flip over. There's still the accuracy, overall accuracy, still very high with a few bits failing. It has topological features such as 2 bits that are near to each other have similar meaning. And Cortical has taken this technology and fine-tuned it and turned, added a little bit of its own magic, very much around converting contract natural language material and converting that into meaningful representations in this type of memory. And the result of that, this encoding, allows for sentences and paragraphs and documents to be compared. They represent similar areas on the memory, and semantically it's possible to inspect a memory for meaningful semantics. So this is technology that Cortical has taken up. So coming back to this question, I've talked about deep neural nets, and I've talked about Cortical's use of SDR, and I mentioned that Cortical's technology is not deep neural nets. Why I'm excited? Well, I've been tracking Numenta, which is an organization that Jeff Hawkins created back in around 2005. And I noticed that in the last few years, organizations, companies like Cortical have begun to work with Numenta and have gone into the field with products. And that really turned my attention, and I reached out to Cortical to find out more about what its work is. And it's applied its AI technology to contract intelligence. This is a topic of today. This technology is wide-ranging, and Cortical could apply it to other areas. What is interesting about Numenta, coming back to this question of AI and deep learning, is that, as I mentioned, deep learning is very much engineering-oriented in terms of its architecture and has limitations for the future of AI. what Numenta is doing is creating AI that is much more closely based to neuroscience and our understanding of the human brain. And SDR has a lot of parallels with the way the human memory is structured. So hopefully that has given you a flavor of why I'm excited about SDR, Numenta, and hence cortical. And I think that it has a lot of future in it. I'll just quote something from a report that we wrote for Cortical recently, our Ovum on the Radar report. We mentioned that Cortical is a partner in Numenta. It's taken SDR to natural language and real-world cases, and it's a statistical-based connectionist AI model, or unlike those connectionist models like DNN, the cortical model is based on the semantic folding features of SDR, which we've just covered. So I know this is very high level. I know it's very rapid, but hopefully it's given you a flavor of what this technology is about, why I'm excited about it. If you want to know more, please do come back to myself or to Cortical to find out more. But this topic of this webinar is really about contract intelligence, and I'll hand over back to Steve. Thank you very much.
Thank you, Michael. So thanks for the brief and informative introduction into artificial intelligence and how Cortical takes a different approach to natural language understanding. But now we're going to switch to a business context for all you who are waiting for that. Artificial intelligence is great. There's a lot of hype around it, but it only becomes interesting when enterprises apply it to real business problems. And what are those real business problems? So one is faced by many large enterprises, legal firms, and consulting companies today. Every day, these businesses have to deal with a wide variety of contracts from multiple sources. They could be leases, credit agreements, purchase orders, or a vast array of other types of legal documents. The business challenge is to review these contracts, understand the key elements, identify and classify clauses of interest, and assess any possible risk. Part of the challenge when reviewing contracts is to be able to compare and classify clauses, even if the wording is different from contract to contract. And additionally, the challenge is to accomplish this review efficiently with high precision while minimizing human effort and reducing costs. Cortical.io Contract Intelligence addresses these challenges. It is a purpose-built artificial intelligence solution designed to improve the productivity of legal review. It can be quickly trained to automatically extract and classify key elements of any kind of legal document. And because it is based on Cortical.io's unique approach to natural language understanding using the sparse distributed representations as described by Michael, the solution delivers precise and reliable results. Best of all, it can quickly and easily be trained by subject matter experts, no AI experts required. Here's some examples of how quickly and easily it can be implemented and the resulting benefits. In one case, a major bank wanted to review ISDA, International Swaps and Derivative Association agreements, extracting over 30 elements with high levels of precision. It took only 70 documents to train the solution, and that's orders of magnitude less than it would be required to train a deep learning system, as Michael described. In another example, a major accounting firm needed to review its clients' portfolios of lease agreements due to change in accounting rules. It used contract intelligence to extract over 60 terms and clauses from the lease agreements, saving significant time and money in the review process. So let's now take a look at the workflow for somebody using contract intelligence. The workflow is straightforward. For any given legal document, a subject matter expert decides which terms and clauses need to be extracted. They then load sample documents and annotate the elements within the documents with a straightforward user interface. After annotating as few as 50 documents, the system is ready to go into production. Once in production, The documents are loaded into the system, and with a simple push of a button, the system processes the documents, automatically extracting terms and classifying clauses, along with providing confidence levels for each extraction. The subject matter expert quickly reviews the extractions and fine-tunes the system if necessary. And then finally, cortical.io Contract Intelligence provides an open REST API, enable integration into any contract management system. One other key feature of the system is that it stores the extraction in a standard SQL database. This allows for the analysis of contracts in aggregate by any business intelligence tool looking for risk exposure, business trends, and other kinds of business insights. Now, let's take a quick look at how the user interacts with the system. Here you see a screenshot of the user interface the subject matter uses to define the terms and clauses they wish to extract. Terms might include parties, dates, or amounts, while clauses are potentially multiple sentences or paragraph descriptions that cover items such as termination, insurance, or use of proceeds. When defining a clause as an extraction target, the subject matter expert can also set up a system to automatically make inferences to classify the clause. For example, whether pending litigation is standard or non-standard. And this makes use of the sparse distributed representation and the natural language approach that cortical.io uses. Here's an example of the interface the subject matter expert uses to annotate the sample documents. They pick a specific term or clause that they had previously set up and then highlight it within the text of the document. Here, they're training the system to identify the description within a lease. Because the description is a clause with inferred value, the system is trained to make inferences based on the description. When the extraction for the description clause was defined, the subject matter also set up options to define the type of property under lease. For example, the choices could include real estate, aircraft, or business equipment. Once trained, the system can classify descriptions even if the wording is different than the original training material. This, again, is possible because the system makes use of cortical.io's unique approach to natural language understanding to provide precise and reliable results, even if the wording is different. When in production, the contracts are loaded into the system. They can either be loaded manually or loaded automatically from a contract management system through an open REST API that cortical.io Contract Intelligence provides. The model is run, automatically extracting terms and clauses in seconds and providing a confidence level for each extraction. The system's user interface makes it easy to navigate between the original document and the extractions. The subject matter expert then can do a quick review to verify the extractions and fine-tune the system if necessary. And this validation could be the final step before exporting the results back into a contract management system if one is being used, or a part of the day-to-day workflow for a subject matter expert. Not only does contract intelligence improve the productivity of contract review, it also creates a database of all extractions. It allows the team to use any standard business intelligence tool, in this case Metabase, an open source tool, to analyze the contracts in aggregate, to look for information on risk exposure trends or other business insights. In this example, reports were run on lease terms, lease deposits, and lease descriptions. As Michael discussed in his presentation, cortical.io's natural language approach, based on neuroscience using sparse distributed representation, provides unique advantages when reviewing the unstructured texts that make up legal documents. The system does a better job of recognizing different phrases that have the same meaning. So it will recognize and properly classify clauses even if the wording is different. This leads to better recall and higher precision when extracting information from documents. It requires minimal effort to train on any kind of legal document. So it's not limited to any particular set of documents, and getting to production on a new document type is very quick. And finally, it is easily trained by subject matter experts. No AI outside expertise is needed. So that's a quick and brief introduction into cortical.io's contract intelligence. To summarize, the features it includes are extraction of terms and clauses based on meaning, not on keywords, automatically classifying clauses based on meaning, definable extraction targets applicable to any contract or document type, extremely short time to train the system, continuous learning through the subject matter expert feedback, extractions that are stored in a structured SQL database format, and it integrates with existing workflows. And just to summarize the benefits of contract intelligence, more precise and reliable results, reduced costs, reduced subject matter expert effort, no need for expensive AI experts, and visibility into the document portfolio. So hopefully that gives you a quick overview. And now I'd like to turn it over to Sascha Demgensky from PwC Germany to talk about his experiences with contract intelligence and other text mining projects. Sascha?
Thank you, Steve. Okay, now let's show you some examples of what we at PwC currently do with contract intelligence by cortical.io in order to make our clients happy because they have some problems. The first thing we will start with is the absolute classic with regard to contract intelligence, and that is we are approached by our clients who sit on piles of documents, and they gathered it over years at times, and they have it all in repositories, but actually they don't know really what's in there. So in my case here, we have a credit institution, and of course they have pretty processes which allow them to file their loan agreements. And of course, at the same time, such information from such loan agreements is also introduced to their risk management engines and other applications they have. But thereafter, things get difficult, because it might happen that the contract side moves on, that amendments come into place. And on the other hand, it's not that easy to keep up with all the different systems for risk management and other things in order to see that everything is still in parallel. So what they are seeking for is some tools by which they can make sure that what they currently have in their contracts is also the values they use for their other systems. And this is a pretty burdensome thing. In addition, nowadays, regulators are pretty straightforward if they have questions about credit institutions' client base and the engagement they have there. So usually our clients get now asked to provide very quickly information on the current status of their business. And this can be very burdensome if you have to do it by hand, checking for 10 or 100,000 of contracts in order to produce a certain piece of information your regulator is asking you. And although the fines for not being able to do this are significantly rising, especially since the financial crisis. Now, the solution we have here with cortical intelligence, contract intelligence, is that we are very efficient in getting to the data. The idea is to transform the unstructured data of the loan agreements into a database based on which you can then put in data analytics and other programs giving you visualization of your data. But the first step you have to do is getting rid of the unstructured data. And doing this by a classical approach with deep learning and statistical operations, this can take some time. If you're lucky and your type of contract is already part of the text mining industry, and there were other clients who did this for the last 3 years, that's fine. Then you get systems out there in the market which need certain adoption, but you can get there within 3 months. But this is not the rule. If you have the next thing, which the other type of contract they didn't have so far, then what you rarely get to answer is that the IT guy asks you, okay, do you have 50,000 agreements, contracts of this type in high quality, and I need some of your experts for 9 to 18 months in order to find out how to make it happen. And obviously, that's very burdensome. Here, with the contract intelligence tool, it's something which happens actually in weeks. Not to say sometimes in days. It's impressive, and we don't need these experts who are quite expensive to stay with us for a long time. We need to understand what they want to get out of their contract. This is usually taking about a week in order to get a target, an extraction target list. And then we need some annotations, and as already was said, we don't need this for 50,000 samples, but we need it only for 50 to 150 samples. If it doesn't work then we have other means than just keeping on pushing samples into the machine. Then we can go and make adjustments to the language model behind in order to get forward. So in end, we have here something where we can provide solutions to our clients' needs within a matter of 3 to 5 weeks, then starting to elaborate from then and enhance the solution. And this is very helpful for our clients. That is an efficient approach to this data. So they can have try and error, they can fix certain things, and they get forward with their projects pretty quick time as money. Another solution where we're currently working with is non-disclosure agreement classification. And there is a situation a little bit different. There you don't have the data all in your files. There you get it from the outside, and you get sometimes lots of that. In certain industries or certain business models, the first thing you get from your business partner is the NDA draft to be signed. And the problem is, okay, you have your own standards with NDAs, and you have now to check whether this external draft meets them somehow. And well, if there is a high number of such NDAs flowing in every day, then you usually cannot push everything to your legal department. There's only a few guys, and they would not cope with it. So in praxis, those things are decided at the front line of the firm, and this is not necessarily the best people to deal with incoming clauses they are unaware of and what to do with it. It's also difficult for them to check for whether every must-have clauses are in there, clauses your own standard requires, otherwise you don't want to engage in the NDA. And also here, we have a solution with contract intelligence where we can check the incoming NDA, have it uploaded in the machine, a first quick check which tells you, okay, these are clauses I already know that they make problems, so you can just turn around on receiving the email if you like so, and 5 minutes later you send out, okay, I already identified 3 things which I think is something we need to just talk about, so the other side is working again, and you have time to get a conclusion of other things the machine told you. I don't know, what is this? Have a close look with your legal department on this. The nice thing is, this is now for NDAs where we're currently working on, but you can have quite the same approach with the same machine if it comes to general terms and conditions, if it comes to software licenses. I mean, these are things which we sign off every day, even as a private person. If we engage in a new app on the mobile phone, the first thing you have to sign is all this data protection things, and then the next thing is the license agreement. You don't read it actually, but if you would like to read it, this is sometimes hundreds of pages. So having something which allows you to make a quick check of what is really important to you and get a quick solution whether there is an obstacle in there is very helpful to our clients. Now, we started with a broader approach to natural language processing, and I also would like to close the circle with a little bit broader application of what Cortical does. Legal research is a wonderful example because it shows the capability. And we're currently working in liaising with legal publishers in order to get grip of their portfolio of commentary literature, of the laws, of handbooks, monographies on certain topics. The idea is to enhance their search engines. Currently, it's quite burdensome to find something actually in law because we are trained for 20 years now to Google it. So we choose 3, 5, maximum 5 words and hope that the hits we get will show us something which is on the topic. Now, what we can do here with Cortical's approach is we can actually take the email by the client or anyone who requested for a legal question, put this into the system and let it compare to every piece of text that is in the repositories of these legal publishers in order to make a match and ask the machine in simple words, what does this email remind you of? And then comes out of the machine, well, these are the statutory provisions I found, and these are commentary literature texts, and here this book is something you should read, it's on the topic. It doesn't tell you what is actually the legal finding in the very end, but it provides you with deep insight in what is out there on the topic. And this is very helpful for a lawyer. If I should assume the part legal research needs in a lawyer's life, I would say around about 1/3 of its time is totally dedicated to it. So if you can have this within seconds, this is very interesting. We are pushing this forward quite heavily. The issues we face there are not that much on a technological side. We face issues on author rights, on data protection, and intellectual property, all the things which make our current legal system so interesting. The technology side, actually, in our project, thanks to cortical.io's technology, is usually not really an issue. Another topic, which is also very helpful to our clients and anybody else invested in electronic communication, is the question, what is all the stuff I'm getting all the day? Our clients get at times hundreds of thousands of emails every day, and they have to cope with it, finding out what's in there, what part of the emails is just an out-of-office reply, what part is advertising. Where are those emails which are interesting? This is client complaints, and on the other hand, a request for proposal or things like that. So classification of email is a huge topic. And there we are currently with clients trying to automate this allocation process so that the process where people work with can focus on the different parts of the incoming email flow. And this is something for regulated industries. The computers help regulators nowadays to create regulation in an even quicker pace every day. And we are coming at a point where it is simply not longer possible to read all the stuff they're pushing out to us. And this is difficult because, I mean, if you are the manager of a regulated company and you are threatened by jail if you are not compliant to certain things, then it might be much better to have an understanding what happens out there and whether there is anything new you should be aware of. So regulatory mapping tries to adjust whatever is in the internal organizational setup or in the internal working papers to the latest version of what is out in legislation and regulation for this topic. And the idea is to match the internal papers sentence by sentence, if you like, so with the different provisions requiring action from the company. And here we use Cortical because the nice thing is, while an internal working paper usually is never using legal language because it's meant for your employees and they should understand it, so it's difficult for wording changes to match with the original provisions in the legislation. And this can be overcome quite easily with Cortical's natural language approach, where the actual wording used is not that much of a topic, and you can provide very quick insight whether certain topics in the legislation found their way into your local implementation at the company. Well, these are the things PwC is currently working on when it comes to helping our clients getting through the mess of text modern computers produce every day for them, and I hope this was a good insight for you. At that moment, I would like to give over to the audience and to Steve for questions.
Sascha, thank you very much, and also Michael, thank you very much for your introduction. We do have a couple of questions. We're running a little long, so we'll take a couple of questions and answer the rest of them offline. If you have any other questions or interests after the webinar is over, feel free to contact us at info@cortical.io. So the first question we got is, how long does it take to train a system on a new document type? And the answer is generally a couple of days. Again, it's 50 to 100 documents, and the process can be made even faster by having multiple subject matter experts annotating the sample documents. Next one is one for Michael. And it says, you've explained why sparse distributed representation is powerful, but why is the rest of the AI community very much focused on deep learning and neural networks? Michael?
Yeah, happy to answer that one. So as I mentioned, I used to work with neural networks. I built products, and I even wrote a book on the topic. Neural networks use calculus. And I don't believe that the way the human brain works uses calculus. I think ultimately, although there are some amazing successes with deep learning, and it will continue to be part of the tool set that we will have in many applications, ultimately as a technology for AI and the future of AI, I think deep neural nets have their limit. Whereas with SDR, yes, there is less awareness, but I believe that will grow because of the way SDR is based on our current understanding in neuroscience. I believe it has a much better future. And as I mentioned, the exciting things that Cortical is doing and the research from the Open Institute, AI Institute, that is Numenta, the work coming out of there, I think is very exciting. So I believe that the future is more along those lines. Awareness will grow. There's a lot more open material on deep learning, a lot of courses, a lot of open source software. Numenta is doing its best to publish its papers, and it does offer some code as well, open source code. It's a question of time, I believe, and I believe that awareness will grow. Over to you, Steve.
Thank you, Michael,
Steve, you're
for the
on mute.
answer. I think I'm off mute now, but I was.
You're off mute now.
So, all good. So, Michael, thank you for the answer. We'll take one more question, and then we'll handle the rest of them offline. The question was, which languages does contract intelligence support? And the answer is, currently we've deployed with clients in English, Spanish, and German. Because of the underlying technology, with some effort, we can basically support any language going forward. So with that, I want to thank our representatives, our speakers here, Michael and Sascha, and I want to thank the audience. And again, if you've got any additional questions, interests, feel free to contact us at info@cortical.io. Thank you, and I'll have a great day.